We're beginning a 4-part series. This is the first part of a 4-part series on analytics. And the topic is going to be the business potential of machine learning and cognitive computing. It's a bit of a buzzword these days. We're seeing a lot of hype in the marketplace, but we'll try to segment out what's practical from what's possible. In terms of housekeeping, we're going to go 1 hour today. We'll stop right at the top of the hour. We will be recording this. This is being recorded. You will have the recording available as well as the slides. And we would like to have you take the survey at the end of this session to tell us how we did, what worked, what didn't work, what other topics you'd like to learn about. My name is still Seth Early, and you can follow me on Twitter. My handle is @SethEarly. You can also follow this discussion using the hashtag Early Roundtable. And don't forget the E before the Y, so EARLEY Roundtable. And we also have the Twitter handles for our panelists. We have Bruce Daley, who's principal analyst at Tractica. We have Olly Downs, chief scientist at Globus, Mitchell Shuster, who's the data scientist with Knowledgeant, and Patrick Heffernan, who's with Technology Business Research. You're going to hear more about them in a few minutes. I'm going to have them introduce themselves. They're going to go through 5 minutes of their perspective, what they want you to take away from this topic, their point of view. Then we're going to have some general discussion and questions, and we'll take questions from the audience. A little bit of my background: I've been in the data science and information technology field for over 20 years. What's interesting is a couple of our panelists have degrees in the sciences, physics and chemistry, and I thought I would throw in that I have a background in chemistry as well. And we're finding that the hard sciences are a great background for any of the analytic work that's going on in the data work these days. Currently work in this field, this emerging field of cognitive computing, but have a long history of working in knowledge management and taxonomy, metadata, information architecture, search, retrieval, findability, and so on. Co-author of a book on knowledge management from the IBM Press, which actually used machine learning way back in the day, in the mid-90s. So we'll talk about what's different today. I'm also editor of the Data Analytics Department at the IEEE IT Professional, and there's a whole bunch of other stuff that I won't bother you with at the moment. So let's talk about some of the core concepts around machine learning and cognitive computing. What is it really? Well, machine learning is a mechanism where we are detecting patterns. We're surfacing information, and that happens through lots of different mechanisms based on statistics and mathematical models of the information. There's a range of different tools and algorithms that are doing this, but one example is a search index. Search is a derivation of structure from unstructured information, and things like clustering, classification, entity extraction, analytics, many of those use machine learning approaches. And what we're seeing now is we're seeing that there are lots of new applications for these algorithms, but basically what they're doing is they're looking for patterns. They're looking for signals from some body of data. And in the case of a search algorithm, we're looking at the user's intent. We're looking at the terms they're using. We're looking at their past patterns and anything else that we can contextualize who they are. So again, a machine learning algorithm is trying to pull back information that is relevant to the user by looking for patterns. More like this is another mechanism for that. Amazon uses machine learning algorithms to provide suggestions about other products that are related. Google uses machine learning algorithms to extract the search relevance. And again, those are the types of things. When we're doing classification using training sets, that's what's called a Bayesian approach. It's using a mathematical model. So there's lots of examples. Personalization uses machine learning algorithms that are trying to, again, predict what you want based on who you are and other signals, right? So this is, generally speaking, some of the things. We're going to hear a whole range of other applications, but I wanted people to understand that machine learning is something that's been around for a while. What's different now is that are changes in technology that allows us to do a lot more, and changes in the algorithms that allow us to do to process other types of data, look for other patterns, and have many other applications for this. So I just wanted to let people know that machine learning has been around. There are new applications. So what's cognitive computing? This is really a newer emerging field, which is really about making computers more user-friendly, helping the having an interface that understands more what you want, right? And again, it's doing the same thing. It's taking signals about what you're trying to do, and it's trying to give you something that you need. So Siri, for example, will answer questions, but Siri also understands context, right? It knows when Siri knows when you're in your car or at home, or when you're moving very quickly and driving versus walking, and that contextualizes the potential range of responses. So Siri understands that and makes it easy, uses a number of different algorithms to make it easier for you to retrieve information. Watson from IBM answered ambiguous trivia questions. It used lots of different metaphors. It used different types of or recognized metaphors and puns, lots of time reference. So it did a lot of things to try to return results in a human-like way. So it's pattern matching, it's pattern recognition, and then there are rules for giving us some kind of an outcome. And again, cognitive computing is a combination of all these technologies that are trying to understand what people want and trying to give them something in a much more friendly fashion. So engaging in a dialogue, understanding an ambiguous query, engaging in a clarification process, and anticipating steps in a process. So this is what cognitive computing is about. Now, artificial intelligence is something that really encompasses all of these tools, solving lots of different problems. It's everything from writing articles, driving cars, detecting fraud, diagnosing disease, a lot of decisions and a lot of judgments that have been typically in the realm of human beings making those decisions and making those judgments. So again, there's a lot that's happening in this space that's very real and very practical. Now today, so I just wanted to sort of set the stage to talk about what machine learning is, what cognitive computing is, and how we're combining these things to build what people are referring to as artificial intelligence. It's interesting, artificial intelligence started out in many years ago with the things that we take for granted today. So, for example, word processing had lots of artificial intelligence because there were decisions that would typically be in the realm of an expert who would make decisions about how to lay out documents. But now all of that is embedded in the software. So again, these things have been around, but now we're seeing a perfect storm of different developments. That's what we're going to hear about today. So what I'm going to do is turn this over to our first panelist. This is Bruce Daley, and Bruce Daley is an analyst with Tractica. And Bruce, I'll go ahead and let you introduce yourself and then give the audience your point of view, your perspective on this topic.
Hey, thanks so much, Seth. Well, I've been in the IT business and the software business now quite a long time, and I started back in the day as an assembler language programmer in an IBM Glasshouse environment. Since then, I've had quite an interesting career in software. I've done about everything that you can imagine, from consulting to finance to programming, and I have been around long enough to have seen the first two AI winters. So recently I was asked to write a report about the practical uses of artificial intelligence in enterprise applications, which is my particular area of interest. And quite frankly, in my entire career, I've never done anything that's had as much impact on my point of view and my view of the world as writing that report. And the reason for that was I came into it fairly skeptically. I had seen companies rise and fall and promises made and broken about it in the past. But once I started doing some research as part of this project, what I soon found out was that AI is being applied in area after area, across industry, and what's really changed is the fundamental concepts have been around for 60 years, and the idea of modeling machines or software on top of human, or really mimicking human intelligence has been around for a long time. What's really changed in the last few years is first of all, there's been some improvements in terms of using probability and statistics. The algorithms for deep learning, and in particular, which is really a form of backward chaining neural nets, has advanced significantly. Secondly, there was a discovery made fairly recently where instead of processing things serially, if you use GPU chips, so graphical processing unit chips, to do floating point calculations in parallel, you got results in an order of magnitude less time. So things that might take weeks would only take hours. And finally, and I think probably most significantly, is the amount of data that's available to train AI systems. And an example of that, of course, is Google's famous cat experiment, where they exposed an AI system to literally millions of thumbnails from YouTube, and at the end of it, without being supervised, the system was able to recognize a cat, and that had a lot to do with how many cat pictures are actually out on the internet. So all that being said, I think if you look across all these industries, and this is really what's changed my perspective, in fact, on the way I look at the world, it's being used for self-driving cars. It's being used, as you mentioned earlier, Seth, in cognitive computing. It's being used in data storage. It's being used to grade tests. It's being used to identify defects in manufacturing. It's being used really in so many ways. I really think it's going to have a lot of world-changing effects.
Terrific, thank you. I'm going to move on to Olly Downs, and Olly is Chief Scientist with Globus. So Olly, why don't you go ahead and give your background and your point of view on this topic, and then we'll circle back for our questions.
Absolutely, thank you, Seth. Yeah, so I'm responsible for the science behind our products at Globus, and I've really had a career spanning physics and applied mathematics at Cambridge University and Princeton, and then out into some of the large industrial research labs, Bell Labs, and then Microsoft Research. And at Microsoft Research really got the bug for developing core science that has direct impact on driving business value. And thanks to my time at Microsoft Research and some early work there in Bayesian reasoning and machine learning, we actually built a solution for traffic modeling that we spun out as Microsoft Research's first startup company called INRIX that now provides real-time and predicted traffic information around the world. And that really got me hooked on building new companies based upon machine learning and data mining, cognitive science capabilities from scratch. And since then, I've helped start and get through to exit a number of companies. Mindset Media, that was sold to Meebo, is now part of Google. Pelago, which is now part of Groupon, does some very interesting location analytics. And part of the common theme to all of this has been really what this conversation is about, which is how do you go from the hype into the practice, and not just practice from a proof of concept perspective, but actually practice that drives business value, and you can actually build a business around. INRIX, for example, just closed a much publicized funding round from Porsche Holdings at a valuation of $550 million. And my perspective on the space is essentially, Seth, if you could hop to the next slide, really that there are kind of three tiers of commercial engagement with these types of technologies. And Seth talked about Siri, work at Google, some of these very large companies where at the heart of the search index, as Seth was referring to, for Google, search results, search performance, ad performance is at the very core of their business. And as a result, their investment is 100-fold, maybe 1,000-fold, even more, what a more conventional business would be. And as a result, there's actually a large chasm between businesses like Google, Amazon, Facebook, Microsoft, Apple, where these technologies are strategic for them, and then they've been able to branch out into interesting other applications like intelligent agents and so on. And businesses where the impact of these technologies could be strategic, but the investment in terms of human resources and tools and technologies are somewhat constraining of these capabilities kind of crossing the chasm. And it's common in my experience to come across businesses where perhaps some of the tools have become more accessible to them, but the know-how isn't. And it's common to hear a company say to me, well, we've tried machine learning and it doesn't work. And so I think, one of the key propositions for machine learning and cognitive computing to really cross the chasm in terms of driving business value is to be able to package up some of these capabilities, perhaps with some specific applications in mind that actually are able to add value without hands-on intervention for a business. That can discover and act without human expertise and provides information and education on what the technology itself is discovering, and with the primary goal of being able to show ROI with pretty limited upfront investment hurdle. And that's really what we've been focusing on at Globus as it relates to marketing. So today, in-base marketing is a relatively slow process that engages at the enterprise level in quite a large number of resources. It's not uncommon for our customers to have 50, maybe 100 people engaged in the marketing process, from planning and audience kind of business intelligence, through campaign formulation and development, and then testing. And the process of testing usually involves, coming up with a few different combinations of marketing proposition, messaging language, and graphical creative, and testing those at a pretty narrowly defined target audience, waiting for a period of time, and then evaluating the performance of those combinations, and then scaling the winning combinations to the entire target audience in the full customer base. The capability we've built takes a lot of the BI and the human experimentation out of the loop and allows us, the marketer, to drive the discovery and continual optimization, both from a language, a price value sensitivity, a value proposition, comparatives, components automatically. And so the machine learning actually discovers and reads out back to the marketers what is the right target audience for a given offer or new product. What is the right language about which to talk to that product, talk to a specific audience about that product. And that scales up the performance of the marketing process by about a factor of 3 orders of magnitude, 1,000 times. And again, this is a packaging of machine learning along the type of proposition I think we need to truly cross the chasm in this space.
Those are great observations, and I think what I saw with Globus was a really interesting application. I met you guys at a conference, but there's a lot of work that still needs to be done to make these things practical. But this is an example of speeding up one of those processes, and we're going to come back to that and talk about what we need to have in place to do this. But I think the idea of those 3 tiers is very interesting. There was a great article in the Wall Street Journal about how Google and Facebook and Amazon were buying up. There's a talent war on. They're grabbing all these PhD data scientists. They're recruiting from universities, and because it's so core to their business. Now, a lot of organizations aren't going to be able to do that, right? But what is practical? What can you do? And there are lots of examples of things that can be put into place to do that. Great, thank you, Olly. Mitchell, why don't you give a little background and your point of view on the topic?
Sure thing, thank you, Seth. My background, I come from a physics background specifically. I am, compared to most of the panelists here, rather a newcomer to the world of machine learning. I have spent much less time in this industry, but I've come to it from a somewhat circuitous route that I think informs somewhat exactly what the power of machine learning is and how it comes about. So, as I said, I have my PhD in physics. I started in sort of a condensed matter, small things sort of world. I took up a job at Intel working on the manufacturing line, doing R&D for developing the next node in the generation of CPUs. And I saw the sort of change in the wind in the terms of the power of AI and machine learning, and what that could really bring in the way of data science and the power that it proposed to bring to all sorts of industries and across a tremendous amount of data and timelines and all sorts of parameters. So I moved into machine learning, and I took up a job with Knowledgeance, which does data science consulting from my point of view. It's actually a broader sort of informational consulting company. And what I do is I really bring that combination of scientific background and obviously programming that everybody on this panel has, and attempt to apply it to clients' problems depending on the context to bring that, that leverage that power of machine learning, and I wouldn't say cognitive computing in these contexts because that's really more of an agency sort of thing, which I think we'll discuss a little bit. But the view that I really want to bring to this and that I want people to take home is that machine learning is a tremendously powerful tool for extracting information from data, but it's not a magic wand. You can't simply say machine learning and all of your problems go away. As has been referenced previously, companies will try this and say it doesn't work, and it's not because the methods are flawed, but there are a lot of prerequisites that go into making this sort of an approach to data work. So it's often difficult to frame your questions in a way that really allow the algorithms that you're using to answer them. Then you have to choose the right algorithms to answer those questions. Data needs to be set up in the appropriate way, and that can be a very time-consuming and complex process. And not everyone has the data that they need in order to answer the questions they want to ask. So there's questions of data cleanliness and data governance, data collection, that all come into play in order to actually apply machine learning to these problems. And then when you finally get a result out, it's very important to understand that result in context, both of the question that's being asked and the data that's being supplied. It's not enough to simply say, well, the algorithm says X, so we should do X. Because that sort of thinking often creates anomalous, there are anomalous behaviors, there are things that really need to be interpreted, and there's a lot of still human potential for intervention here. The marketing algorithm can tell marketers what's working the best. The marketers still have to make some selections and have to understand the market and know where it is that they should be, applying their expertise in order to leverage the information that's being brought out by the machine learning process. In addition to that, the cognitive computing, as we said with Siri and Watson, is really all about dealing with the context and the ambiguity and being tolerant of those factors and being able to incorporate them into the decision-making process. It's a scaled-up version of machine learning, and it brings together a lot of disparate things, but it's not so different from machine learning in its fundamental underlying context. But all of this depends on having large amounts of data and knowing what kind of questions to ask and what kind of questions you can answer and what it is that surrounds, all of the environment and infrastructure that surrounds that, which is extremely non-trivial. So it's very important to have the right people who have the right knowledge, as well as the right information, or I should say the right data, in order to extract the right information, to be able to formulate the right questions and then to understand and know how to interpret the answers that you get. So if I had to sum this up in one sentence, I would say, beware the hype. What's, as it says at the bottom of the slide, what's possible is not always practical, and what's practical is not always desirable. So understand where machine learning can bring its power and where data science can really leverage itself for the benefit of businesses, and apply it in the appropriate context and in the appropriate situations.
That's great. Thank you, Mitchell. And what's interesting here, I like your framing of cognitive computing it's context awareness and tolerance for ambiguity are really the two primary identifiers. So what is it doing? A cognitive computing interface can answer a question as though you're posing it to another person. And what's interesting is it doesn't necessarily have to leverage machine learning. We built an application for Allstate, and this was actually for their business lines of insurance. It was Allstate Business Insurance called Abu. And this is a search tool. And basically, because we could make that search so context sensitive, there was we used a text-to-speach and an avatar. So they had a little, character talking to them, and this was for agents who are filling out underwriting forms for complex insurance applications. And because you could break this down into very clear steps, we could write the algorithms that could very, very accurately present the next step for those users. And people would come in the morning and type into the chat window, "Good morning, Abby, how are you today?" because it felt more natural. So in any case, but that didn't necessarily use machine learning. It used a lot of rules. It used a lot of carefully tagged and curated content. It used semantic search. It used a little bit of natural language processing. I mean, there's machine learning in there, but the application was built leveraging those tools with very, very clear outcomes. So I think this is a great way to frame this, is that in being clear about the problem you're solving, understanding what the components are, what do you need as prerequisite in terms of data, how do you formulate those questions that you're seeking to answer, what are your hypotheses? As Olly was saying, you know, the marketing application has to start with your marketing offers in your program. So there's a lot of work that needs to be done to get these things right. Okay, let's carry on, and we'll introduce Patrick Heffernan. Patrick, do you want to go ahead and give your background and your perspective?
Sure, great, thanks. I think I might be the only panelist without an advanced degree in a hard science that you're going to hear from today. But I do have an advanced degree in diplomacy, and I spent 13 years doing that. And then I spent 6 years doing competitive intelligence for a Big Four firm. Currently, I run the professional services practice here at Technology Business Research, and we cover management consulting, IT services broadly, digital business intelligence, healthcare IT services, the whole wide range of things. So my background in diplomacy and competitive intelligence and business analysis really informs where I'm coming from on this particular topic, truly from the business perspective of it. And we're looking at how companies are adjusting their models in selling services around machine learning and cognitive computing, especially when it comes to consulting. And my basic take on this is I see sort of three large fears. When you look at the IT services vendors, so these are the folks who should be bringing these possibilities to the market. I mean, this is the IBMs and the Accentures of the world. They're afraid. They're afraid of being behind their competitors. As much as they understand the potential, they're not sure they can. There's two big fears. They're not sure they can make a compelling business case, a convincing business case, and then they're not sure that they have the resources to really address these. We've talked a little bit about the talent issue, and I'll get to that in a minute, but really recruiting and retaining the right people for the IT services vendors who truly really rely on IP and people, having the right people makes all the difference, or they're also RANs. The second big fear comes from potential clients, that is the companies, the businesses which could benefit from machine learning and cognitive computing. And the real fear here is pretty simple. You know, can I afford it, or can I afford not to do this? Am I already competitively behind? Am I throwing good money at a pointless fad? And that really gets to a business element of this in terms of the investing in cognitive computing. I think when you take a step back, everyone truly appreciates the potential of groundbreaking technology, and every C-suite decision maker has an iPhone and understands the truly radical nature of IT in our personal and in our business lives now compared to, say, 15 years ago. I mean, you don't need to make the case anymore about how important technology is and what it can do. The challenge then still remains, is this the right investment? And then finally, the third fear that I look at when I see this space is the IT folks themselves, who are wondering what happens to their work when the machines take over. And we've done some research into robotic process automation in business process outsourcing, which sounds a lot like word salad, but what it basically means is the robots doing the work in a call center, for example. And we've seen that at a very general level, applying this research across a lot of companies in the space, basically one RPA, one robot, can replace 3 people and have an immediate impact on costs, as much as a reduction of as much as 25% immediately. And that is when you include, when you factor in implementation, when you factor in the change management, and even when you factor in ongoing monitoring. So as we've seen in digital and cloud, in business intelligence, it's the lower skilled IT services folks who are in the most trouble. And then at the other end of the skills scale, you have the data scientists with an MBA and 7 years of industry experience. It's what we sometimes call a people unicorn. It's the person who can translate business needs to machine learning possibilities to analytics and then back to the business. And that person is in huge demand right now. And that means that top talent and being able to find it, retain it, and manage it is really what makes all the difference. So I'll give one quick concrete example of what I'm talking about. Accenture has been working with an alliance partner, it's IPsoft, embedding cognitive computing into Accenture's BPO, business process outsourcing offerings. And you can listen to the employees' spin on this, and that's that Accenture is eliminating jobs, or you can take the Accenture sort of spin on it, that they're creating more time for their employees to help clients with really truly higher value services. But what's really happening when you come down to it is that Accenture is laying off people in BPO or retraining some of those people in that service line to do other work in other service lines. And so who are the folks that are staying with the cognitive computing enabled BPO offerings? It's those folks that actually can deliver higher value services, those ones who can translate analytics into the business problems, who can formulate a strategy that gets tested. And so the real immediate impact on business models of the IT services vendors that we're looking at is an increased premium on people and IP. It was already a high premium, and it's only getting higher. These companies have to make a choice. Are they going to invest in cognitive computing? Look at IBM. Watson's already been mentioned. Look at Wipro. They've made cognitive computing an important pillar for them going forward. And really truly building out their own capabilities. On the other hand, you have an Accenture who to some degree is just partnering, and they're providing those high-skilled, high-priced, high-margin, high-value consultants and leaving the IP aspect of it to others. So, at TBR, we're going to continue advising on which business model makes the most sense, but overall we're looking at how this entire space is potentially the kind of change that you look back in 15 years, like an iPhone, like the internet in many ways, that completely upends the way that businesses are run and business models have to be adjusted.
Yeah, thank you, Patrick, and those are really great points. There is a lot of fear in the marketplace of either not catching this wave, being left behind, or having your business model upended, and certainly we're going to be seeing that in the coming years. So part of this is saying, well, where do you need to invest in? What do you need to do, and how do you sort of get started? One thing I had mentioned, some of the work that we had done for the insurance company, and again, there's a lot of things that were in place to make that work. Right? They had a very clearly defined problem. They had good content processes. All of that was more tweaking and refining to make it more user friendly and to fulfill the goals of the project. But so let's just toss this out to the panel and where do organizations get started? That's always a good question, because how do we invest? How do we explore? We don't want to miss something. We don't want to put money in the wrong direction, resources in the wrong direction, but at the same time, this will change business models. Who would like to begin with that?
Hey, I'd be happy to address that, Seth. Bruce Daley here.
Great.
So when I'm asked that advice, what I like to tell people is that there's a number of open source AI projects, for instance, H2O.ai. And my estimation is that this technology, while it's not always going to be successful, it has the potential to be successful enough that, as Patrick was talking about earlier, it is going to impact IT organizations, and they would be wise to start to get some experience in that. And I think working with an open source AI package is particularly valuable because one of the issues in AI is obviously transparency. So if you're using it for credit scoring, which a number of companies like LendingTree are, and someone gets turned down for credit, if you call customer support and ask, well, why did it get turned down? The answer is, well, we don't know. The machine turned it down. So one of the advantages, I think, of working with an open source AI package is that you start to be able to understand a little bit about how it works and how you're going to be able to address those issues in the future. And incidentally, as part of our research, what we found is that because AI applications in general and deep learning applications in particular are both compute and storage intensive, we expect that there's actually going to be a higher multiple for support. And typically, I think, enterprise software packages range anywhere from 2 to 4 times as much revenue spent on installing them, customizing them, really taking them to the point where they're practicable. And we estimate it's going to be even higher, maybe even as high as 5 or 6 times. So I think there's a lot of opportunity there, and at least at this juncture, open source seems to be the way to go. But Patrick might have some thoughts about that too.
Sure. Yeah, let me turn it back onto one of the other presenters in just a second. By the way, folks, you can enter the questions in the chat window to the right. I do know we had a little bit of challenges with the slides advancing. We don't have a lot of slides in this deck, so it's really just a discussion. So who else would like to add to that in terms of where to get started? Patrick, did you want to follow on with some discussion points?
Sure, absolutely. The one thing I'd add, and I think you're absolutely right. Start with what is out there, open source. I also in talking to the Accentures and the IBMs and the PwCs of the world when they're advising their clients on this, the first step is almost always to get in the room the people who have a business problem that have to be solved. You have to know what it is you're going after, what you're applying any of this technology to, and in many cases the folks, it may used to have been the case that your typical line of business leader didn't really care about what the IT solution was. They just wanted it solved. I think that's changed now, and you've got a lot of business leaders that have a familiarity, at least, with the IT, with the technology possibilities, and they know what is at least out there in vague terms. What they need is that guidance to say, okay, how do I apply what I know can be possible to the business problem I have? And maybe that's the step we're going to get to next, which is what's possible, what's practical, and what actually can get done. Not always all the same thing.
Yeah, and I think that trying to understand what problems people are facing today in information access and information management, in decision making, in support, in customer service. There are lots of problems out there that lend themselves very well to these types of technologies. And don't invest in a black box and a vendor promising the moon. Mitchell, you had that was sort of your takeaway. How do you tell what's possible and what's practical and what's achievable for a given organization?
I'll jump in a minute. Just let me say one more thing on the educational aspect of actually using these technologies, which is the education really needs to happen at all levels. There's sort of this prevalence of a belief that has I think perpetuated since IT became a major industry, which is that some people just don't need to know how certain things work. And I think it's increasingly important that just as you expect a CFO to read a financial statement without necessarily expecting to do it on a day-to-day basis, you need to start having your leaders really understand, and then even your lower-level employees understand how to use these tools and what's going on with them so that they can use them properly. Okay, but now getting to, so what kind of problems can we solve? There's a rather large array, and I wouldn't even say that there are problems that can't be solved with these sort of machine learning approaches. It's down to what kind of data you have and what kind of questions you're specifically asking. So we can, we've seen some examples earlier in the presentation about a vast array of fields and kinds of questions that can be answered. It really comes down to what is it that you have available to answer with. So that really comes down to what kind of data sources you have, where they're coming from, either external or internal sources, and then how much you can trust that data, how clean it is, how well organized it is, what kind of data governance has been around it, so that you can then, when you go and ask a question, which, as I said, a little tricky sometimes, that you can trust the answer that you're getting. which is, I think, the bigger barrier really than saying, what kind of questions can you answer? It's more, what do you need in order to answer that question? Can you get it? Do you have it? And can you trust the input so that you can trust the output?
Great, and I'll just go back to some of these other questions here, but Olly, I know you had some perspective on getting started, the education. I'll just let you add your thinking here, especially around trying to understand what is appropriate for a particular organization. How do people really tell what they can do and what's practical?
Yeah, I think that the challenge is, I totally resonate with what Patrick is saying, which is that you have to have a bit of a cultural shift or decide to truly get the best out of these capabilities, that the culture of the business is going to be oriented around analytics and the kind of a no excuses approach to understanding at least some of the output, or having some fundamentals in terms of understanding the outputs of these things. And then in terms of practically getting going and understanding what's feasible, I think a lot of efforts today, first stab efforts today, they either tend to get bogged down in infrastructure and the the challenges that Bruce and Mitchell alluded to with getting the data in place, and perhaps focusing on getting IT efficiencies, perhaps in data warehousing and aggregation processes, rather than focusing on trying to solve perhaps a relatively simple but soup to nuts problem that can show ROI at the very highest level, where it impacts business functions in a company rather than just it's a technology activity that impacts technology stakeholders. And it's always a challenge, because you have to have a cross-functional initiative to pull that off. But then again, it makes the business value much more apparent to the high-level stakeholders. It also forces part of this process of becoming more analytically minded across the business, because you engage multiple functions. And then you also have a lot of buy-in, because you're not just about cost savings, you're actually driving some appreciated high-level business value.
So that's a really important piece of this, is to just say, we can investigate, we can innovate, we can try to experiment, and many times organizations will do that. They'll have their IT organization do some investigation, but it really does need to be focused on a real problem and a real business pain, and otherwise it's a science project, right? So making sure that we understand how we can solve that particular problem and make sure there's alignment. And I think that, as Mitchell was saying, that's a great opportunity to be educating your business stakeholders around what's possible, right, and what's practical. So there's a lot of education that needs to happen. There's a lot of business analysis, and I think, Bruce, you had talked about the unicorn, the person that can translate between the business side and the technology side. So that type of communication and engagement and education is incredibly important. So where do organizations get that kind of education? What do they need, and how do they get educated? So Bruce, would you like to take a stab at that?
Well, I haven't seen a lot of unicorns in my career. I've seen a lot of jackasses and a few donkeys, but I think at this point it's clear that all AI is really based on a strong mathematical foundation. In fact, you could argue philosophically that is its perhaps greatest limitation. So from that perspective, I think we alluded earlier to how many of the panelists have a hard science background, and I think that's absolutely indispensable. And at least at the moment, though, I think there's a lot of self-learning that people have to do. I'm not really sure that there's any specific roadmap. Certainly one of the things that I was surprised about when I did my study is, one of the things I found is there's been over 150,000 papers written on neural nets over the last 60 years. And as a result, what I see is these applications are all springing up like mushrooms in different parts of the world, sort of independently of one another. And some of them are going to be very successful, and some of them aren't going to be successful at all. So without some sort of scientific approach and a willingness to accept failure and the learnings of failure as an outcome, I think that there really isn't a roadmap, in my estimation, to follow. But some of the other panelists may disagree.
So I put up a slide which has a number of resources that are at varying levels of technical detail. But yes, what are other folks' opinions? Olly, I think we could ask you what other applications you're seeing that are appropriate, and then where else organizations can find out about some of this stuff and get a deeper education.
Yeah, we're seeing, boy, it's just exploding. In my background, we kind of started out in some interesting spaces where my PhD advisor was John Hopfield, who invented one of the key flavors of neural network, actually, and worked on some of the earliest applications of what now has become known as deep learning. Actually, surprisingly, those world-renowned innovators at the United States Postal Service, of all places, actually have one of the oldest deep learning implementations that exists, which is actually a dedicated piece of hardware used for handwritten zip code recognition. And they deployed that in 1987. But now, of course, deep learning becoming a very topical technology with a lot of focus on image recognition and so on. And also that branching out into domains like medicine, where you have medical imaging and things like that, a lot of work there with these technologies. And then, Seth, as you were talking about, a lot of applications as it relates to language, both spoken and written, and understanding linguistics, and particularly in domains which seem arcane, but there's a lot of business value there and a lot of inefficiency, like in medical billing, medical readmittance, bill prediction and fraud detection in the medical space. I personally have done a lot of work in varieties of uses of technologies that improve the efficiency of markets, and it's important to remember that a lot of this, some of the early applications, again, of machine learning and early neural networks were in finance and hedge funds. And of course, we've seen some notorious failures of the mathematics underpinning some of these things in recent years, or at least in the last decade. But financial applications are obviously key, in the modeling of risk, which is kind of modeling this ambiguity that we were talking about earlier, come into play. So it truly is exploding, and we do a lot of work in auction marketplaces, understanding the true value of things, understanding what it costs to win an auction. Think about places like eBay, and also what people are doing in real time with display advertising, where an ad is actually now bid on in a second price auction in real time while the web page renders in your browser, so less than 300 milliseconds.
So, by the way, I did want to point out that Tractica has done a research report, the one that Bruce had referred to, and if you do want to purchase that, you can get a courtesy discount or professional discount based on this call. So that might be a good place for some people to investigate. So interesting in terms of those applications and all of these different areas that are emerging. What are you seeing, and Olly, you can take this because you're specifically in this space. What are you seeing in terms of the application to digital marketing, and are we able to determine buyer characteristics and customer needs through these types of approaches? And it's not an opening to sell them your software, but but you can educate them. But you can educate them about it.
I think the interesting thing that's happened in digital marketing as a whole is, of course, online display advertising is, and search advertising back to Google is where some of these things started. And I think actually that space is kind of in a second wave of innovation, somewhat driven by what has happened in Europe around privacy, and is kind of beginning to appear here in terms of what and how you can use data effectively. And actually what that's done is produce a new wave of innovation around how you use perhaps softer context or behavioral information to understand an individual and really kind of be cognizant of them without actually knowing specifically who they are, which has been kind of the challenge for the space over the years. And then, of course, what's happened is a market economy has developed around advertising of all types, be it in games, in apps on your mobile device, be it online more conventionally, be it in other measurable media, digital signage, and so on. But where the business that best understands the individual or individuals who have the potential to see that in marketing interaction actually better understand the value of that impression or view to that customer. And so that is what's driving kind of efficiency in the marketplace around advertising and display. But it's highly focused, particularly as we push more and more to more and more anonymized information. Actually pushes more and more into those who can be more sophisticated in their analytics in terms of understanding the customer that they're trying to interact with.
You know, and there is that is an incredible space. There's clear ROI. There's it's easy to see the impact of doing these things. Digital marketing is a tremendous application area. There's a question that we had from the audience about what do you need to have in place in order to make these things work, and our perspective is you still need an architecture, right? These things are not magic. I was at the MIT CIO symposium last week, actually, and they were talking about all these wonderful things around machine learning and cognitive computing, and systems that write articles, and they write articles about sports, sports results and earnings reports and so on. Those things have structure, and you do need to understand what the structure is and what the rules are, and have those components to assemble. You do need to have offers that you can present. You do need to understand your customer attributes. You do need to have a mechanism to pull data from lots of different sources. You're assembling all of this experience for your user. You're using these tools to enhance that and to improve your results, but you have to have this architecture that spans these different systems and processes. Those are table stakes, right? The systems, there are tools that use unsupervised learning approaches where it will just look for patterns in data, and that's great. But you still have to say, what are you looking for in the data, and what are you trying to get? And you do have to have reasonably good data. I mean, if your data is bad, yes, you can get rid of some of that noise, but you do have to have the data and the structure and a process to make that work. I just wanted to put that up just to kind of give people that context. Let's see, we have a couple of other questions here. How would you distinguish big data and data science in regard to machine learning? Who'd like to take that one?
I'll give a stab at that. This is Mitchell. I would say that you wouldn't distinguish them because they're not the same thing. Big data and data science are, themselves sort of, big data is what you can use to do data science. It's part of how you get that large amount of information you can then apply to your algorithms so that your algorithms can work on. Remember that machine learning, the thing that distinguishes it from traditional computing is the idea that it gets better as it progresses, as it works, as the algorithm runs. So the more data you feed in, the better, the more accurate your results become. So big data and data science, I would say, sort of go hand in hand in that you need one to do the other. And the big data is only really valuable if you can extract information from it, which is the job of the data scientist. And then machine learning is really just the way that is accomplished. It's the toolbox that you use in order to grab that information out and find the patterns and learn what it is that's buried in there that you can't see, but which, with enough time and enough processing power, the computer is able to extract for you.
I'd also like to add, if I may. Well, go ahead, Seth.
No, go ahead. I was just going to, please.
Well, I was just going to add that at least in my mind, some of the distinction between AI and big data is sort of the difference between a lake and a stream. is when I think of big data, I think that you're collecting lots of information that you're going to wade through and try and find that elusive trout of understanding. Whereas in the case, I think, as Michael alluded, AI systems and deep learning systems are designed to really improve over time, and so they can really function on a stream, a narrow stream of data that's continuous, that modifies itself over time. So, clearly, I think of, at least personally, as big data as an integral part, to machine learning. But at the same time, I think it's really a subset. And in fact, sometimes you can accomplish it with transactional data that really you wouldn't normally think of as big data.
And we are actually going to be having another session next week. We're going to be talking about the Internet of Things, and we're going to be talking about big data and how those pieces fit together. But we'll also do some definitions and some foundational information there. But another question that came in: what's the relationship of big data to cognitive computing? And really, these are, again, they're components, right? When you think about what cognitive computing is, a concept. It's a way of making computer technology more friendly to humans and to human interactions. And big data is just another component, if you will. And Bruce mentioned the stream of information. When we're looking at all these signals, we're looking at real-time click behaviors and search terms and, what I call the electronic body language of our users. When we're looking at all these behaviors and we're harvesting and surfacing information from the social graph and social media and Twitter types of messages and other types of social media messages, that's a huge amount that moves really, really quickly. We can interpret that and we can leverage cognitive computing to make that understandable, because again, there's so much data that's being created that humans can't process it. So cognitive computing is a mechanism to make that data actionable, to be able to apply it to solve a business problem or to be able to apply it to answer your question, right? So there's huge streams of data coming from lots of different places. How do we understand that and interpret that? Someone want to add to that?
Seth, there's a really good example of that. I'm sorry, I was going to say there's a company out of North Carolina, Artificial Insights, and they can take scores from any game, professional, college, amateur, and turn it into a narrative, turn it into a sports story.
Yes, that was actually one of the presenters at the conference, and that was one of the topics that I said, well, look, there's no magic here, right? But yes, automated insights. They write something like 1 billion articles a year or something crazy. But it also does personalization, right? It also tries to understand the characteristics of those audiences and then makes those articles more specific to those audiences and creates all those variations in the final output. One thing I was going to say, we talked about hardware. We talked about the fact that there's been changes in hardware. Years ago when we did machine learning with some of the Lotus technologies and IBM technologies at that time, it took 3 or 4 days of continuous running to build that first index, right? So it had to iterate through all of these algorithms and to process a body of content, and I don't remember the details of how big the body of content was, but to go through the corpus and to train the categories and to build those indices, it took like 3 days with really heavy-duty hardware and beefy servers. I also like to say that IBM with Watson spent 3 years and $25 million and then has $15 million worth of hardware. Give me $40 million in 3 years, I'll solve your knowledge management problem, right? But there's been huge changes in the technology, in the algorithms, in the hardware, in the storage capabilities. And right now, all of these things are coming together, and you're just going to see enormous changes in the information environment. Quick 30-second final thoughts from each of our panelists. I know we're right at the top of the hour. Bruce, 30 seconds.
30 seconds. I think AI is real, and you need to take it seriously.
Terrific. Olly.
Yep, definitely real, but be prepared to embrace it with the entire business culture, not just the techies.
Terrific. Patrick?
Ollie, you stole my thunder. It's all about culture. It's beyond just the tech. It's what you're going to do. That's what matters.
Terrific. And Mitchell?
And just understand that you need to have everything in place in order to do it, and don't expect to be able to do it without some real background.
That's terrific. Well, thank you to our panelists. Next week, we're going to be talking about mining business insights with big data analytics and the Internet of Things. Another tremendous, we're going to hear Bruce Daley is going to be back once again. We're going to have another panel. I thank you all for attending. Thank you to the panelists and Sharon and Dave for all that work to make this happen. So we will look forward to seeing you next week, and the recordings will be available. Don't forget to fill out the survey. So thanks, everybody.
Thank you, everybody. Bye.
Thank you.